Very good morning, children. Welcome to SVS e-learning class. This is your physics subject teacher Feroz Khan from SVS High School. In the last class, that means in the live class, we have studied about the mass-mass relationship problem in the chemical equation. Yes, children? And I asked for how many percentage of you understood about that mass-mass relationship problems. Some students have said 100%, one or two students said 1000%. But when I give the homeworks to you, I just given you 4 questions for your homeworks. But you have done 3 questions and one you cannot do. That also done by two students, only 2 students. So from that I understood many students did not understand the topics, the mass-mass relationship in the chemical equations. So the same topics we are going to be continued today itself. Okay, children, let's start over the topic. Okay, children, there are 4 relationships. They are mass-mass relationship, mass-volume relationship, volume-volume relationship, and mass-volume particles. So the first one, the mass-mass relationship. So for this we have to take the standard mass of the element. Standard mass you have to take. Standard mass of the element can take, or standard mass of the compound also you can take. Okay. So the next one, the mass volume. So mass volume. So same as the mass, you just take a standard mass, you take it. Standard mass compare with its volume. Remember, every molecule or compound or element, it has one standard volume. The standard volume is 2.24 liter. This is the standard volume of an element or compound. You will understand now. Okay, next volume, same, just to take the standard volume. We know the standard volume. Standard volume you just have to be compare. You have to compare the standard volume. We know the standard volume, that is 2.24 liter. That is the standard volume. Next we know the mass volume particles. So for this we have to take, we understanding standard mass of an element, standard mass. And next volume we know 2.24 liter. And now particle. Okay, particle, that is 6.022 into 10 to the power of 23. This is the standard particle. So this all are the things is mainly related to the standard. So we have to be compare the element or compound with the standard unit. So the mass of standard unit what will be? We know that which element we are taken, that element in mass will be its standard. That element mass will be its standard. You will understand now clarity. Okay, and the volume we know 2.24 liter. 2.24 liter is the standard volume. And next we know the particles. Okay, so the particle 6.022 into 10 to the power of 23, and this one only we are called as a Avogadro number. What we have called a Avogadro number. This you have to study in the 9th class. Okay, Avogadro number. So Avogadro number only we know that is 6.022 into 10 to the power of 23. That is the Avogadro's number. Okay, so that is the standard. So this is some of the small information to understand the relation. So we will study one by one relation about mass, volume, and mass volume particle one by one. Okay, children, understand? Okay. Okay, children, to understand better about the chemical equation problems, you must want to understand a topic, mole concept. Mole concept. For example, we can look here, just we can write as a H2O, that means water. So what is the weight of the water and how to calculate the weight of the hydrogen? We know hydrogen is equal to 1. How many hydrogen are present? 2 hydrogen. So 1 into 2, we know that 2. And oxygen weight is how many? 16. Yes, how many oxygen are present? Only 1 oxygen. So 16 ones are 1. How many? 16. The total how much we got? 18. Yes or not? So we know the weight of the water is 18 gram. Weight of the water is 18 gram. Got it, children? So listen very careful. Here we observe that 18 gram of water has a 6.022 into 10 to the power of 23 particles. 6.22 into 10 to the power of 23 particles, as well as it also has a 18 gram is equal to 1 mole. 1 mole. So what is 1 mole? Simply understand 1 molecule. So this mole, how we are understanding, based on the coefficient. So what the coefficient will be, okay, what the coefficient that will be taken as a mole. Taken as a mole. So easily we can understand, taken as mole. The coefficient, just to look over the coefficient of this water, that is we know 1. So that's the reason I written 1 mole. Did you get or not? So if in fact here there is a 2 present, if there is a 2, so what will happen? I will write here 2 mole, and also what also will be changed? This also will become 36 gram. Are you understanding or not, children? Okay. And when the mole changes, so when the mole changes, now look at 18 gram for 6.022, then 36 gram. 36 gram will be how much? 12.044 into 10 to the power of 23, because it's become double. Got it, children? Okay. So one things we understand now. Same things here. Over there we can take a hydrogen. So now hydrogen, only just hydrogen. So this hydrogen also, how many moles are there? Just look at the coefficient. How many mole? 1 mole. So we have written here 1 mole. Okay. And how many particles are there? We know 6.022 into 10 to the power of 23 particle. Why? So you wondering about 18 gram also 6.022 into 10 to the power 23. And hydrogen also 6.022 into 10 to the power of 23. Its weight only just how many gram? It just 2 gram. Yes or not? 2 gram of the hydrogen also 6.022 into 10 to the power of 23. 18 gram of the water also 6.022 into 10 to the power of 23. So it's make it wonder. Yes or not? So why this happening? Here whole playing the main thing is mole. Who playing here? Mole. So just to not look in the mass, just not caring the mass, only just to observe the mole. So look at here also hydrogen before 1. Here also water before. Just we can take, okay, here also water before there is a 1. Yes or not? So that's the reason we can understand both are same. If in fact here hydrogen before 2, yes or not? If here hydrogen before 2, what happens? This will become 4 and this will become 2 mole, and this will be 12.044 into 10 to the power of 23. Yes. So what is the reason to changes this happens? Because the mole is changed. So this all mainly related to the mole. Okay, understanding or not? Okay, you can take the standard mass, standard particles and mole also. Okay, children, listen. So the sodium mass, just here we can mention the mass, and here we can mention mole, and here we can mention particles. Okay, so the mass. So sodium mass we know that is a 23 gram. 23 gram. How much mole present? You know, in the front of the element, what the number? That means coefficient. So we know 1. How many particles? Then we can write this 6.022 into 10 to the power of 23. Yes, because based on the mole, not caring the mass, based on the mole. Okay, so the next one, hydrogen. We know how many gram? Hydrogen 2 gram, because it is a diatomic, so we have written as H2. And how many mole present? And so don't look this number, we have to look after the coefficient. So 1 mole. How many particles? 6.022 into 10 to the power of 23. So here also you observed the same things happening. Now oxygen. We know how many oxygens are present here. Okay, here also mole we are looked under number of atoms. This 2 is mentioned, number of atoms. Here also how many number of atoms of oxygen are present? 2 number of atoms. So that means we know 32 gram. Yes, children? Yes, 32 gram of oxygen gas. This is oxygen gas. Oxygen gas. 32 gram of oxygen gas. And how many present? How many number of volume? Only 1. Yes. So the mole is only just 1. So what we have written 6.022 into 10 to the power of 23. Okay. So just rubbing these items and making to understand one more thing. Listen. So if I write here oxygen, only just oxygen. So now what happens? Now we know only 1 atom of oxygen. So we are writing 60 gram of oxygen. This is oxygen gas. When you ask the question, write the formula of the oxygen gas, nitrogen gas, hydrogen gas, you must mention the diatomic. Only just oxygen or nitrogen or hydrogen, just you write as a only symbol. Okay, here this is the oxygen element. How many gram? 16 gram. How many mole? 1 mole. How many particles? 6.022 into 10 to the power of 23 particles. Got it, children? So observe here, this is also oxygen, this is also oxygen, but the mass are different, but the mole particle are same. How does it happen? Because of the coefficient, the friend of that element depending for the mole and the particles. Got it? So the mass did not depend for it. Got it, children? You are understanding? So in fact, question asked about the 2O. 2O. Then what will be the answer here? How many oxygen are there? 2 oxygen are there. So it will become 32 gram. 32 gram. How many mole are present? 2 mole are present. Can you understand? Look at coefficient 2 there. So 2 mole are present. How many particle will be? 12.044 into 10 to the power of 23. That means 6.02 into 10 to the power of 23 into 2. So what we will get is 12.044 into 10 to the power of 23. So I hope you are understanding about the mole concept. It did not depend for the mass, it mainly depended for the mole and the particles. Mole and the particle. Otherwise the particles will depend on the mole and the mole will depend on the particles, but they never care about the mass and they only just look in the coefficient. Coefficient they are looking. Got it, children? So through this you can understand very easily about the mole concept. So particle we know and mass and the mole. Got it, children? So related that some of the problems we will do now. Okay, children, the first question here it is, calculate the mass of the 0.5 mole of nitrogen gas. Calculate the mass of the 0.5 mole of the nitrogen gas. So first step we have to compare what relation it is. First step we have to compare what relation it is. We know here asked the mass. Here asked the mass relation. Yes, mass. And here mentioned the mole. So we know this is the mass mole relationship. Mass and the mole relationship. Got it, children? Okay. So mainly this is the mass and here it is the mole. So it is a mass mole relationship. So we understood the itself. So in next step we have to take its standard. We have to take its standard. So which gas is mentioned here? Nitrogen gas. Yes or no, children? Nitrogen gas. So we know the 1 mole. Yes, 1 mole of, and why we have written 1 mole? Because the mole in standard unit is 1. Every time already we know the standard unit of the mole, that is 1. So 1 mole of nitrogen gas, here clearly mentioned gas. So whenever gas comes, you should be writing N2. Got it, children? So 1 mole of nitrogen gas is how much gram? So nitrogen N2, because mass mole relation. Already mole written, now we have to write the mass. Okay, so nitrogen N2. 1 nitrogen we know 14 gram, 2 nitrogen it will become 28 gram. Got it, children? So we have taken the standard values. First step, understand the relation. Second step, write its standard. So next one. Here question, in next step we have to check over what questions are provided. So the question provided here is 0.5 mole. So in the place of 1 mole, you just write 0.5 mole. 0.5 mole of nitrogen gas. Nitrogen gas is question mark. Got it? So we got idea. So same before I said the step model. So what we have got? So 1 is equal to 28 gram and 0.5 is equal to question mark. So what is the step to do? Same as go just up and up. Okay. So what we will get from the question mark? From the question mark we know just went upside down. So we know 28 gram. 28 when it comes down into 0.5. And just going upper divided by 1. Got it, children? Okay. So now we can get understanding is no need of cancel, whatever cancel the same will become. So 28 into 0.5. So it's a half of it we are doing. So the answer will be 14 gram. That will be 14 gram. Got it, children? Because 28 into 0.5. 28 into 1 means 28. But 28 into half, that means we know that 14 gram, it will be, it's a half will be. So what is the answer? 14 gram. So once observe 1 mole 28 gram, then 0.5 mole 14 gram. It's very easy. Yes or not, children? So one more question we can look at. 3.011 into 10 to the power of 23 particles of oxygen gas. Find its mass. Find its mass. What is the first First step, find out the relations. What is the relation here? Mass particle relation. What the relations happen here? Mass particle relation. So we know that how can you find that problems? Listen. So we second step, find its standard value. Find its standard value. So here mentioned 3.011 to the power 23. So already we know particle standard value, whatever element, whatever mass it is, the standard particles we know 6.022 into 10 to the power of 23. So we have written 6.022 into 10 to the power of 23 particles of oxygen is, okay, 6.022 into the power of 23 particles of oxygen is, how much we have to take its mass? So O2, one oxygen is 16 gram, then 2 oxygen we know 32 gram. Got it, children? 32 grams. So we have taken the standard values. So understanding this step, first step, find out the relation. Second step, from the relation, write the standard value. So we have written. Next, go to the question. Question provided 3.011. So what will you write here? So you write in 3.011 into 10 to the power of 23 of oxygen gas is question mark. The real question has calculate the mass. Got it, children? Okay. So what will write you? 6.022 into 10 to the power of 23 is equal to 32 gram. Are you understanding? So 32 gram. Then 3.011 into 10 to the power of 23 is equal to question mark. Got it, children? So same as before process, you just do this model. We can understand. So 32 into 3.011 into 10 to the power of 23 by, just gone upstairs. So 6.022 into 10 to the power of 23. Got it, children? So what we can do? This and this will be cancelled. How many times? So look in, this is a half one, yes or not? So here 2 times are there. Got it? Now we can cancel this 2 and this 32. How many? We can get about 16 gram. So what will be the answer? 16 grams. So look it same. 6.022, that means the full 32 gram means that in half will be the mass in half. Got it, children? I hope you are understanding well. Okay, so one more question we can do. Let's look it. Okay, children, the next question here mentioned 1.12 liter of carbon. 1.12 liter of carbon, calculate the mass. So first step, understand the relation. What the relations are here? Mass, volume relation. Next step, write it standard. What is the standard volume? We know that 2.24 liter, that's the standard volume. And of carbon, the carbon mass we know it is a 12 gram. Yes, okay. So we got 2.24 liter of the carbon is 12 gram. Then 1.1 liter of carbon is question mark. Got it, children? So same as the before process. So 2.24 is equal to 12 and 1.12 is equal to question mark. So when we go just up and down, you will write here, you can understand 12 into 1.12 by 2.24. Yes, children? So we are just cutting this. How many times it will go? 2 times. And the same, this 2 will be cancelled and this 12. So what will be the answer? Answer is 6. So we will get 6 gram. So look at here also, this is the standard full value 2.24 is 12 gram means then 1.12 liter of carbon will be 6 gram. Got it, children? So I hope you understood the calculate, how to calculate the mass. So next we will study about the calculate of the particles. Okay, children, we are now going to find out calculate the particles. How to calculate the particles? Okay, children, listen. So first we have to understand about the relationship. So what the relationship are here? We know the number of particles and the mole. The relationship is number of particles and the mole. So we know that first we have to take the standard value of the mole and the standard value of the particle. Here there is no relation of the mass. Only particle and mole, So just to take the standard value of the particle, standard value of the mole. We know the standard value of the mole, that is 1. So we written 1 mole of who? Water. 1 mole of water contains, 1 mole of water contains how much particles? We know the standard value of the particles 6.022 into 10 to the power of 23. Yes children. Now how many mole are given here? 0.5 mole. So 0.5 mole of H2O contains, yes or not? Contains question mark. We know that. So say simple process we can write very easily 6.022 into 10 to the power of 23. How we are doing? Same as this process we are doing into 0.5 by 1. Yes or not? So we know that when this multiplication with the half 0.5, then whatever the number here is there, that number in half will get the answer. So we will get the answer is 3.011 into 10 to the power of 23. Got it children? So think in how much very easy this problems. Okay, yes. So let's do next one also. Okay, the question is here 80 gram of magnesium oxide. So first step, understand the relation. Here the relation is particles and mass. Because gram is mentioned, so mass, particle and mass is the relation. Okay, so we have to take the standard value. So 80 gram provided. So first we have to check the standard mass of the magnesium oxide. Already I said whenever if you want to find the standard mass, you just calculate the weight of the compound or element. So we know the magnesium we know it is a 24 gram, oxygen that is 16 gram. So total we will get to 40 gram. Yes or not children? 40 gram. So we written about standard. So 40 gram of magnesium oxide. 40 gram of magnesium oxide is equal to how many particles? 6.022 into 10 to the power of 23 particles. Yes or not? 6.022 into 10 to the power of 23 particles. Then question asks the 80 gram. So 80 gram of magnesium oxide contains question mark. How much asked? So we can write the same process. Very simple. So 6.022 into 10 to the power of 23 into 80 by 40. Yes, so we can cancel this 40, this 80, and 2 times, and we will get 6.022 into the power 23 into 2. So it will be answer 12.044 into 10 to the power of 23. Okay children, so very easy to do this one. So we completed how to find the calculating of the particles also we have completed. Got it children? Yes. Next we can understand calculate the moles. Calculate the mole. Okay children, let's look. Also before we have studied calculate the mass, calculate the particle, and now we are going to study about the calculate the mole. Okay, all the process are same, only few steps you follow is very easy to do. The first step, understand the relation. Second step, those relations in standard value, right, and just compare it, it's over. Yes, okay, so here also we are the same process we are doing. The first process, find out the relationship. What the relationship here? Mole mass. How I am understanding there is a mass? Because the gram is present, so it comes to the mass. So the mole mass relationship. What relation? Mole mass relation. So just a step, I am writing it's a standard value. So what is the standard value? 50 gram of calcium carbonate. So we have to find the value of the calcium carbonate. We know the calcium is equal to 40 gram, carbon is equal to 12 gram, and this oxygen is equal to 16 gram, but 3 oxygen present, so how many? 48. So what will be answer? So 40, 52, and we know 100. Yes, total will be 100 gram. So I just written as here 100 gram of calcium carbonate. 100 gram of calcium carbonate is equal to 1 mole. Why I written 1 mole? Because I know the standard value of the mole is 1. So 100 gram of calcium carbonate is equal to 1 mole. Then 50 gram of calcium carbonate is equal to question mark. Same as before process, just make it this, we can understand. So 1 mole is equal to, we can write here 1 into 50 by 100. So we can cancel this 2. Got it? So 2 times. That means we got answer 1 by 2, or we can write 0.5. 5 mole. So answer is 0.5 mole. Okay, 1 mole 100 gram means then 50 gram, we know very easy, 0.5 mole. Got it, children? So one more problem we can do related to the mole. Okay, the question is here, 3.011 into 10 to the power of 23 of sulfuric acid. Calculate the mole. Okay or not? So what the first step, find out the relation. What the relation? Mole particle relation. Mole particle relation. Got it, children? Okay. So the particle, we know the standard particle of the sulfuric acid. Already we know whatever the element, whatever the compound, we know the standard value will be one specific number. There is a Avogadro's number, we know 6.022 into 10 to the power of 23. Yes, 23 particles of sulfuric acid is equal to 1 mole. Observe, children, I did not take any weight here because the relationship is mole and particle. So first I taken the standard value 6.02 to 10 to the power 23 particles of sulfuric acid, that is 1 mole. Then question related 3.11 into 10 to the power of 23 is equal to question mark. Yes, children. So same as the before process we can do. So what we have to do? 1 into 3.011 into 10 to the power of 23 by 6.022 into 10 to the power of 23. So how can we cancel this? This will be cancelled 2. So what will be answer? We got the answer is 1 by 2 or 0.5. 1 by 2 or 0.5 mole. 0.5 mole. So here also answer we got 6.02 to 10 to the power of 23 is equal to 1 mole means then that in half, that the particles in half, same will be the half of the mole. Okay, children. So I understood about the mass relation, particle relation and mole relation. So we can look about the volume relation also. Okay, children, let's look. Okay, children, the question is here, calculate the volume of 4 gram of hydrogen gas. 4 gram of hydrogen gas. So what is the relation? Volume mass relation. Okay, children. So first we have to understand the standard weight of the hydrogen. So here mentioned hydrogen gas. So the standard weight we have to take S. So one hydrogen, we know that the hydrogen gas means we should mention H2. Already I said the hydrogen gas, if asked, we should write H2. So one hydrogen 1 gram means 2 hydrogen 2 gram. So we know 2 gram of hydrogen is equal to 2.24 liter. Why I am written 2.24 liter? Because 2.24 liter is the standard volume. Whatever element, whatever compound it is, 2.24 is the standard volume. Now question asked 4 gram of hydrogen. Then question mark. So very easy to do about, same as this process, and direct writing also very easy only. Anyway, we can do 2.24 into 4 by 2s. So what will be? This two will be cancelled. So 4 will be cancelled and answer will get 4.48 liter. 4.48 liter. So very easy. So 2 gram 2.24 means the 4 gram 4.48 liter. Okay, let's look at one more question. Okay, children. The question is 12.044 into 10 to the power of 23 particles of calcium hydroxide. So the relation is volume and particle. So what is the standard particle? We know that is 6 point. So 6.022 into 10 to the power of 23 is equal to, what is the volume? The standard volume. You don't care about any mass because the relation is volume and particles. So the standard volume is 2.24 liter. Yes, children, 2.24 liter. So now what the question is provided here? 12.044 into 10 to the power of 23 is equal to question mark. Okay, children. So now the same process we are doing things. Listen. So 2.24 into 12.044 into 10 to the power of 23 by 6.022 into 10 to the power of 23. Okay, children. So we are cut this and this also we have cut. How many times? 2 times. So 2.24 into 2, we got the answer 4.48 2.48 liter. So very easy. Already we know standard is 6 point means we know that's double, it is a 12 point. So standard is 2.24, then that in double will be 4.48. So I hope children you all well understood about the mass relationship, mass volume relationship, and mass particle relationship, and volume. So whatever the relationships, all the relationship we have to understood. Yes or no children? So I hope you can do now whatever the questions I provide them. So today whatever how I explained for you the problems, same problem, same pattern, you just do it. And I will give you some more questions for as your homework. When you done this homework, then I can understand you understood the topics very well. Okay, so same as before, those who watching this video, just write your name in the comment section, and also I like to get some feedback about this video. Okay, whatever you write, just true comment, just write under this comment section. Okay, so that's all for today's class children. Thank you so much.